Welcome to your last day of graphing tangents, reciprocals, all this, because this is our last notes of Chapter 8. Let's jump on in. We're graphing each of these for one period. First thing with tangent, I don't know why, but it should say y equals, because you know this is an equation. It's tangents. We're going to think of our period being pi. What's important is we're going to actually think of it as negative pi over 2. To pi over 2, that's the easiest with tangent, because then we'll get our asymptotes. So solving this, we're dividing everything by 2 pi. So I actually get negative 1/4 to 1/4. Yeah, that sounds right. So those become my asymptotes. Looking at this scale, I don't like it. Let's change it. How about this becomes 1/4? And this can become negative 1/4. On those points become our asymptotes, because that is where our function is undefined. That's where cosine, the denominator, is 0. Then we're going to know that our x-intercept is always in the middle. This is a tangent function. Normal tangent increases as you read. And there we go. Did everything we needed. Asymptotes, x-intercept, and our formation. Moving now to cotangent. When we look at cotangent, again, the period is pi. So in this case, we want to look at it as so. We're going to look at it as 0 to pi. Again, this is best for cotangent so that we can find the asymptotes. First thing, add pi halves to both sides. Divide every side by pi over 8. We'll be left with 4 to 12. That's my new starting and ending asymptotes. Looking at my graph, what if we do more changes? How about every 4? So this could be 4, 6, 8, 10, 12. Yeah, we can do that. Make it a little, we'll go by 3s. So if this is 4, 1, 2, 3, that's my middle, 1, 2, 3. That could be my 12. Yeah, start, end. Those give our asymptotes. Again, however you scale is your call. But get our asymptotes at 4 and at 12. That means our midpoint here, our x-intercept is at 8. This is a cotangent, so as you read left to right, it decreases. And that's all you need. If you find the phase shift, it'll give you those asymptotes, and then you graph. Another cotangent for good measure. Remember, cotangent has a period of pi, so we're going to go 0 to pi. We're going to divide every side by pi over 2. Or multiply every side by 2 and divide by pi. You know, the algebra, your call, you do what you want. Here creates our start and end asymptote. So just take away the pi's. It's just going to be 1, and that's just 2. Those are your asymptotes, 0 and 2. Here's your x-intercept because it's directly in the middle of 0 and 2. It's cotangent, so it decreases as you read. Last one is a secant. Remember, secant, the reciprocal is cosine. So first, I'm going to graph y equals cosine with all of these phase shifts. That's my first priority. So cosine has a period of 2 pi. So 0, my bx minus c to 2 pi, because this is cosine. Add pi thirds to each side. subtract pi thirds to each side. Divide every side by 3. And this now gives you your start and your end. So I'm going to start at negative pi over 9. And then I'm going to get to 5 pi over 9. So to be even, how do we go by 3s? Ignore the scales again. Remember, you need to have your 5 points, negative pi over 9. And we end at 5 pi over 9. We're going to add these up. Divide by 2 to find your midpoint of 2 pi over 9. Add these up. 5 pi over 9, 2 pi over 9, you get 7 pi over 9. Divide by 2. 7 pi over 18. And this one would be pi over 18. This is a cosine function, no change in amplitude. So we would start up at 1, middle, down, middle, up. I'm going to do a dashed line here because this is not my answer. This is the cosine. And now I graph my secant. Everywhere we have our x-intercept, that's an asymptote. My max point now keeps going up. Minimum point goes down. Max point goes up. And that is 1 pi length of secant 3x plus pi over 3. You may add in these curves, but it's not necessary. That would be your answer. Hopefully, this reaffirms or reviews some of your graphing elements. If you have questions, make sure you ask them. Good luck and happy end of Chapter 8.